Yes. Huh? No, that was our introduction. So now we're going to start recording this. All right. So this will be on our YouTube channel. So if you guys need help, extra help tonight when you're doing your homework, all right. So we have a little introductory video.
Distributive property. To multiply larger numbers, the distributive property is helpful. The distributive property combines addition and multiplication. It says that you can multiply the addends of a number and then add the product. Chef Cora hard-boiled 6 dozen eggs each day to make egg salad for sandwiches. What is the total number of eggs Chef Cora uses each day? There are 12 eggs in 1 dozen, so find 6 times 12. Think of 6 times 12 as 6 times 10
So this is what we just did over here,
6
correct?
times 2.
All right.
We can use an area model
And here's
to
our
model
area
the
model.
problem.
So this will tie it into what we did
6
on
times
last
10
Thursday.
equals 60. 6 times 2 equals 12. Add 60 plus 12. So Chef Cora uses 72 eggs each day.
So all they were doing is they were taking our 12 and breaking it down into 2 different multiplication problems. So 6 times 1 is 6, and then remember they bring the 0 down behind it, so that was 60. And then you add the 60 to 6 times 2, which is 12, and that gives you your answer of 72. It makes difficult math problems easier. And it also, this part, the distributive property of multiplication, so you can distribute out to an addition problem. All right? This is very important when we get into algebra further along. All right? All right, so we're going to do a little bit of review. At the beginning of the year, we started talking about place value in digits. We're going to use each of these digits, 1, 9, 7, 2, 5, and 6, exactly 1 time to write the greatest number. Then we're going to use those digits again to create the least number. And we're going to say how much greater is this number than the least number possible, using each of the digits exactly once. Okay? We talked about, hopefully you guys can remember, how will we create the greatest number given a set of digits like this? Which number am I going to start with when I start writing my greatest digit?
9.
Why? I'm sorry, there was 3 people. Why am I going to start with 9? Because it's the largest number and has the greatest value, right? And if we start with that, where's it going to put us on our number chart? The further left we go on our number chart, on our place value chart, what happens to the digit?
It's greater.
The value is the greater, right? So we have to start with our largest digit in the greatest place value. So if I'm starting with the largest, where am I going next?
7.
7. So the next greatest number, that next greatest digit, it goes in the next greatest place value, right? Where are we going to go from there?
6.
6. All right, go ahead, tell me. 6.
5, 2, 1.
Okay, so if that's the greatest, connect this real quick. So we have 9, 7, 6, 5, 2, 1. If that's the greatest digit, what's the greatest number possible using the given digits? What is going to be the least number possible? What digit am I going to start with to write the least number possible? Anderson?
1.
I'm going to start with 1, right?
Yes.
Okay. So 1. What comes next? Bridget?
2.
2.
5.
5. Is it
6.
6? 10? 7? And what's the last digit?
9.
9. Okay, so now we have the greatest number possible with these digits and the least number possible. All right, so we started with our greatest digit in the greatest place value to create our greatest place number, and then the least, as we go down there they're in order from the greatest digit to the least digit. That way their values are in the greatest place value possible. To create the least digit, we started with our smallest digit in the greatest place value, and we worked the same way back. All right? So now, what do we have to do with these in order to find how much greater this number is than the least number? So we have the greatest number, and we have the least. What do we have to do with them to find out what the difference is?
Subtract them.
Would have been awesome if you raised your hand. But yes, we're going to subtract them. Okay? Now we can't subtract 9 from 1, so we have to regroup, right? So 11 minus 9 is 2. I can't subtract 7 from 1, so we have to regroup again. So 11 minus 7 is
4.
I can't subtract 6 from 4, so I have to regroup again. So 14 subtract 6 is
8.
5 subtract 5.
0.
7 subtract 2.
5.
9 subtract 1.
8.
So, what is the difference between the two digits? 850,842. All right. All right. Then we also did some table problems last week. All right. It says Chloe wants to save $75. She saves $5 the first week, $10 the second week, $15 the third week, and so on. How many weeks will it take Chloe to save a total of $75? Yes, sir. So we want to create a table. Our table, what's going to be the top numbers on our table? The number of what?
75.
Yes, sir.
The number of money.
The amount of money. What else are we going to look at? So we have the amount of money, and the other thing we have is, yes?
How many weeks?
How many weeks? So the amount of money is going to change, right? You see, the first week she had $5. The second week she saved $10. And the third week she saved $15. The number of weeks, they're going to go in order. 1, 2, 3, 4. So we want to use the number of weeks on the top of our chart. So, number of weeks. One, 2, 3, 4, 5, 6, 7. I don't know how many weeks we're going to have, but we're going to create our chart this way. Okay, so there's the number of weeks. Now what's going to go underneath the number of weeks? What is going to go underneath the number of weeks? Mr. Pinion. Mr. Pinion. Why did I say Mr. Pinion? I'm sorry. What's going to go underneath the number of weeks? We said we have the number of weeks. What's that? What else? The amount of money. So underneath there, we're going to go money. So, and it's the money that she has what? What is she doing with it?
Saving.
Okay, so the money saved. So how much did she save in the first week?
$5.
So that goes here. And then in the second week she saved.
10.
Third week she saved.
15.
So if she keeps saving like this, what is she going to save in the fourth week? Brendan?
20. It goes by pattern.
What's our pattern? By fives. Very good, Brendan. You found a pattern. So it's 20, and then what's next?
25.
After that,
30. 35.
and in the seventh week, 35. Okay, now, it's going by 5 every week, but is that how much money she has that week?
No.
She saved $5 her first week, right? And how much did she save the second week?
$5. $10.
$10. So how much money did she have in the second week? Because she had $5 in this first week, right? So this is our total. She had $5 in the first week. So the second week she saved $10. So how much money does she have now?
15.
She has $15 now, right? So how much money does she have in her third week?
30.
And in our fourth week?
35. 60. 30. 50.
Look at her chart. How much did she have in the third week? 30. And in the fourth week she saved how much more?
$20.
So it's 50. And in our fifth week?
75.
Now how much were we looking for?
75.
75. So are we done? How many weeks did it take her to save $75?
5.
Bridget, you stopped paying attention, huh? Come on, follow along with us. Okay. So it took her 5 weeks. All right. Now we're going to get back to what we're actually going to do today now that we've done a couple review problems. Okay. The distributive property. Why is the distributive property an effective method for multiplication? What did we say it was doing with problems like 56 times 3? Why does the distributive property, why is it effective? What would make you want to use it? We have 56 times 3, correct? We talked about this problem earlier. What would, if we were going to use a distributive property, like we did with our area model, what would we break 56 into?
50 plus 6.
Now, why would we do that? Yes.
Stop regrouping.
To stop from regrouping. And if we don't have to regroup when we multiply, what is the multiplication problem easier or more difficult?
Easier.
So, if we break a number like 56 apart into two numbers that are easier to work with, we make the multiplication problem simpler. Okay? So that's why it's an effective method. So here's an example of that. All right? We have 5 times 48. They're using our area model. This is the way that we did it on Thursday, okay? Today we're going to start using parentheses. So they took 48 and they broke it apart into two numbers that are easier to work with, 40 and 8. Okay? Because 40 plus 8 equals 48. And according to the distributive property, we can take a number and break it apart as long as the product of that number is the number that we started with, and we have to multiply both numbers by our multiples. So we started with 5 times 48. So now we have 5 times 40, and we have 5 times 8. And then we have to add the products together, okay? So 5 times 40 is
200.
200. Because 5 times 4 is,
20.
and then we have to just bring our 0 down behind our 20, right? So that's 200. Then 5 times 8 is
40.
40. So 200 plus 40 is,
240.
so there's our answer. So why is it an effective model? Because it takes multiplication problems where you have to regroup and makes it into simpler problems to where you don't have to do that. Okay? So we're going to do it with 6 times 37. Only this time, you guys are going to tell me what we're multiplying by, but I'm going to show you how we're going to use our parentheses and our order of operation in order to use the distributive property. Okay? So the first thing I'm going to do is I'm going to take the beginning of our problem, right here, 6 times. So we're going to have 6 times. Then we're going to have an addition problem that's going to make 37 easier to work with. So what are we going to add together to make 37 two different numbers that are easier to work with? I can see some of you are already starting to use our area model. All right, we're going to get away from this. We're going to start using parentheses. Follow along. Erase the model and come back. Yes, sir. I'm sorry, everybody else could react. 30 plus 7. Okay? So, once I'm here, now I have to distribute my multiplication, the multiplication part of my problem. So I have 6 times on the outside of the parentheses, correct? So I need to give that to the 30, and I need to give that to the 7. So I'm going to have 6 times 30. I need to put that in parentheses, and then I'm going to add that to 6 times 7 in parentheses. Okay? So, my first parenthesis set, right here. My first set of parentheses, we have 6 times 3, which is 18. And then we bring our 0 behind the 18, correct? And our next one, 6 times 7 is?
42.
42. So 180 plus 42 is? That was fast. 222. 222. There's our area model of 240. And here's our next model. That's what we just did. All right. So now we're going to do our first example. Go ahead and open your books to page 119. Yes, 119. Okay, so now we're going to look at taking what we learned last Thursday using our area model, and we're going to translate that and turn it into using our distributive property, using order of operations, so we're going to start using parentheses and everything else. All right? So here's our area model. We have 3 times, it says a field trip of 42 students each paid $3 for transportation. Use mental math. So we're going to use mental math. We're going to do this in our head, and then we're going to put it on our paper, okay? And the distributive property to find out how much money was collected altogether. So we're going to find 3 times 42.
120. Wait.
See?
Whoa.
Shh. Hold on. We're going to do it in our head, but we're not going to shout out answers, okay? All right. So we're going to break. In order to do this in our head, we're going to use our area model that they have given us right here, okay? So we're going to go 3 times 4 is, we know 3 times. We're going to bring the 0 behind the 12, so that's 120.
20.
Then we have 3 times 2, which is,
6.
and then we have a 120 plus 6 is,
126.
all right, so see, we can do that all in our head without doing math on paper. Okay, so that's mental math. Now, we're going to write 42, just like we did before. We're going to take 3 times 42, and that's going to equal 3 times what plus what in my parentheses? No, we're not there yet. We're starting from the beginning here. We have 40 plus 2. Okay? When we apply the distributive property, we're taking the 3 times and we're giving it to each one of the numbers inside the parentheses. So 3 times 40 and 3 times 3 times 40 is,
120.
and 3 times 2 is,
6.
our total is,
126.
and so how much money was collected?
126.
Ooh, not what I wanted to do. That's fine. I think that. I meant to change the page and I closed it. Sorry, class. Alright, so we're going to do one more example. Alright. So we're going to get away from using our area models. So in our next example, they're not giving us the area model. Because the area model was to move us and help us transition into using the distributed property. So we have 7 times 26 equals 7 times, and in parentheses, what's going to go inside our parentheses? Tell everybody.
I know.
20 and 6. So 2 numbers that we can easily do mental math with, right? So we have, once we have this part, what do we have to do next? We're not multiplying yet. We have to do something. We have to do something with this. What are we doing? You're way too excited. Williamson? Put it in parentheses, but it's called something. What are we doing with it? What are we going to do with the 7 times? We're going to distribute it to our addition problem. So 7 times
20.
plus 7 times
6.
All right, so we have to distribute the multiplication portion of our problem. So 7 times 20 and 7 times 6. All right, we have to distribute it. We have to give it out. Okay, 20 and 6 came to your house, and you have to give them stuff. You have to. They have their plate sitting in front of them.
40.
You're distributing their food. Okay. All right. So here we go. Now, mental math. 7 times 2 is.
14.
7 times 2 is 140. 7 times 2 is 14. What do I do with the 0 after the 2? Bring it down. Okay? Then 7 times 6 is
42.
42. 140 plus 42 is 182. So 7 times 26 equals what?
182.
182.
Wow,
Good job. Okay, class. All right. So there's your two examples for you in case you want to go back and look at them when you're at home tonight. All right, our guided practice problems. Tonight I'm going to ask you to complete all of the independent practice numbers 3 through 10, and then on the back side, the problem solving to number 15. We're going to do the 2 guided practice problems right now. Okay? And then you guys will have a little bit of time to work on some homework, or your classwork, your independent work, I should say, today. All right? So, our first guided practice problem, it says 5 times 18. So 5 times 18, and this is going to equal, now they're giving us a bunch of the numbers, so it's going to make it probably a lot easier than what you guys are going to see. So we have 5 times our parentheses, blank plus 8. So what's going to go in our blank spot? 10. Very good. So now what do I have to do with my 5 times? Devin, what do I have to do with my 5 times? What am I going to do with this part of the problem right now? I'm going to multiply it by what? Okay, I know I have to multiply it, but how do I do it? What's it called? I'm going to distribute it to my 10 and to my 8, right? So I'm going to have 5 times. What's going in my first set of parentheses below? 5 times 5 times 10. And then my parentheses next to that, 5 times
8.
Okay. So now some mental math. 5 times 1 is 5. I bring down my 0 behind my 5, right? Okay. Then 5 times 8 is 40. 5 plus 40 is
90.
So 5 times 18 equals
90.
90. Very good. Alright, so we're going to do the next one over here. 2 times 21. So we have 2 times
21.
2 times 21 is our problem, right? So now we're going to move on. We're going to start breaking it apart. So we can use our distributive property to solve this using mental math. So we have 2 times what plus what?
20 plus 1.
20 plus 1. So now we come down. What do I have to do with my 2 times?
I did like 20.
What? Look at what we're doing. What do I have to do with it? Cooper? I have to distribute it to my addition problem, right? So I have 2 times 2 times 20 and 2 times 1. Okay? So 2 times 2 is 4. And I bring my 0 down behind it. And 2 times 1 is 40 plus 2.
42.
So 2 times 21 is
42.
42. Okay, tonight when we're doing our homework, or I should say right now when you're doing your classwork, I want to make sure that you guys are showing your work. So when we go 6 times 13, make sure, just like in our samples, you're going 6 times 13 equals 6 times your parentheses, and that's your 6 times, add that, 6 times, okay? And then I want to see that you're adding together the products of these 2 multiplication problems to get your answer. So you see how we're laid out right now? Okay? This is how I expect your work to be shown tomorrow. This is how I expect to see you showing your work today while you're doing this in class.
Okay.
So, 6 times 13 equals 6 times, parentheses, something plus something, then 6 times plus 6 times those products added together to give us a sum, which will give us our answer. Okay? Please do not skip any steps. All right. I'll be coming around. If you guys need some help, raise your hand. I'm going to go through these slides real quick. That way, if you decide that you need some extra help tonight. Don't forget, as normal, if you get stuck on some of the word problems or anything, you and your parents can go online to the YouTube video. And what will be on the YouTube video?
The answers.
Now, what is going to be required of you to show me when you So if your work has not been shown,
It's wrong.
okay. Remember, it's not so much the answer that I care about, but it's the methods in which you reached your answers, okay?